Welcome to part 2 of this video tutorial. First thing I want you to do is let's expand our primary CLX logic. And if we go in there, recall that our auto mode indicator is controlled by an auto start PB, and we also have a auto stop PB. Now previously we called those external soft PBs. Okay, so what I want to do is simply change the instruction comment. Instead of external soft, let's just say client HMI for both of these push buttons, and add the same comment to the auto mode indicator. So I'll go offline to do that. So you notice I've updated the stop and start for the auto mode to add client HMI for both the start, stop, and auto mode indicators. I'm going to go ahead and download and go online with that code, throw it into run mode. And with that code back in run mode, I'm going to go back to my factory talk view project, go into my primary area, so area number 1. And what we should have up here is some specific tags that are being monitored from our variable frequency drive. And now we need to add a start and stop push button, and of course an indicator that relate directly to the auto mode in our primary CLX. So let's go ahead and add those start stop push buttons with an indicator. So here we've got two objects that I've added to the screen for start and stop. I'll go ahead into my connections. Okay, I'm going to refresh all folders. Then I'm going to minimize anything that's open here. Go into my primary CLX, which is my packaging area, into my online tags, and of course this is going to be my auto mode start. And I'll do the same thing for the stop push button. Don't forget to configure the stop push button as a normally closed push button. And lastly, I'm going to add an indicator. It's your choice what kind of shape or object you want to use for this. The indicator added, I'll connect this to my auto mode on indicator, of course, from my primary CLX logic. Okay, I'll save my screen up, then I'll go ahead and test it. Alright, so I hit start, I hit my stop. Okay, so with that functioning, I'll hit the stop push button. And the next step is to do this exact same thing for each of the other areas, for area 2 and area 3. And of course you already created the tags with your start stop memory circuits in areas 2 and 3. So go ahead and do that now. Add start and stop buttons to each of those screens. And of course the indicators on your process overview screen will be monitoring, or will be a duplicate of the indicators that you add to each area screen independently. Go ahead and complete that and come back for the next step. So at this point in the lab, what you should have is a start and stop push button on each of your area screens, complete with an indicator. That indicator is duplicated on your process overview screen. So if at any point in time, if I hit play on my packaging area, for example, and I hit the start button, my indicator goes green on both my area screen as well as a process overview. So you have some redundant checks that the operator can use here. So I'll go ahead and stop that. And as another example, if I go into my secondary control logics, which is my mashing screen, and I do the same thing, throw it into play mode, I hit the start push button, sure enough, my area running indicator highlights, so does the one on my process overview screen. So the operator can see from either the area running or the overview exactly what the status of the mashing area is. However, they have to go inside the mashing area screen or display in order to start or stop the process. So with that complete, I want to draw your attention to the screen that I have open. So what you want to do is open up your secondary control logics area screen. So area 2, mine happens to be mashing for a beer process. And the first thing you need to do is create numeric displays for each of the variables that you're going to, or that you've already determined you're going to record on this particular secondary control logic. So for example, for area 2, I've chosen to monitor the mixer speed, the temperature, level, and pressure. So in the order of process variable 1, 2, 3, and 4. Now, in order to, these are of course all text boxes here to, or add labels to the specific tags. But in order to get my actual variable numbers to change, well, this is where we need to connect these numeric displays to the process variable tags inside the secondary CLX code. Hopefully you follow me. Of course, this is a one-way conversation, so I need to assume you can. Of course, if you can't, make sure you get a hold of me outside of this video, and let's get this sorted out for you. So what I'm going to do is go into my numeric display for mixer speed, for example, and because that was my process variable number 1 that I recorded in the table in the lab itself on step number 11, I need to connect this display to the process variable 1 tag in my secondary control logics code. So in order to do this, I'm going to go into my numeric display, and you notice I've already connected down through my mashing area my secondary CLX shortcut process variable 1. So if I go into my tags, we'll see exactly where that exists. So through my mashing area, secondary CLX shortcut, my online folder, and because mixer speed is my process variable 1, I'm simply going to select that tag, say OK, and of course that's what shows up in my expression. Now, one thing I haven't talked about yet is the check syntax. So if you were to do any math on the inside of this window and you want to check to see if it validates, simply check syntax and it will tell you if it's valid or invalid in this particular text box. So with my field length appropriately formatted, I'm going to let you format that based on your experience now. I can say OK, and then go back to the display and hit the save and then play button. Now what's happening here is my mixer speed is responding, or should respond to the waveform that's connected to process variable 1. So you notice it just went from 85 down to 81, and you'll also notice that the other 3 variables on my screen are responding to waveforms from behind the scenes. So I've already configured temperature, for example, to process variable 2, level to process variable 3, and of course pressure to process variable 4. What this does is it allows it to drive our display. Of course, we're focusing on getting the data up to the operator. So now it's changing in the background as long as my mashing area is running. So what you want to ensure is if you added the mashing system enable properly in the logic is that when you hit stop button, of course, the variables themselves stop changing, and you notice the mashing area on my process overview is at the off state as well. When I hit start, we continue on, and the variables continue to change. So this is a very powerful thing that we've done here in terms of building up our logic file or our HMI. Now we're monitoring 4 variables that are being dynamically driven from that logic file. So to complete this particular section of the lab, what I want you to do is do the exact same thing with 4 variables now on your boiling screen. Okay, with 4 specific variables that you choose. I have 3 here. I have 1 more to add, so you take care of yours and connect them to the appropriate addresses for waveform number 1, 2, 3, and 4 in your Slick controller. Once you've tested the start, stop, push buttons on each area and ensure that your monitoring tags shut down as soon as you hit the stop push button, you can carry on and move on to the next part of the lab.